Is a giant asteroid really going to threaten Earth in 2029? Let's dive into the science and get the real story about Apophis. It's a fascinating celestial visitor, and understanding its path is key to putting concerns to rest. The asteroid, known as Apophis, first entered our awareness in 2004. Astronomers at the Kitt Peak National Observatory spotted this new object in our solar system. Its discovery immediately piqued scientific interest due to its orbit. Named after the ancient Egyptian god of chaos, Apophis quickly lived up to its name, at least in terms of initial uncertainty. Its path suggested a potential close encounter with Earth in the not-too-distant future. This made it a priority for further observation. Apophis isn't just any space rock, it's classified as a near-Earth object, or NEO. This means its orbit brings it relatively close to Earth's path around the Sun. There are many NEOs, but Apophis stood out. More specifically, Apophis was designated a potentially hazardous asteroid, PHA. This classification is given to NEOs that are large enough to cause significant regional or even global damage if they were to impact Earth, and whose orbits bring them within a certain distance of our planet. It's a label that triggers closer monitoring. Early calculations of Apophis's orbit after its discovery raised some eyebrows. The data suggested a non-zero probability of impact during a close approach scheduled for 2029. This possibility, however small it initially seemed, was enough to warrant serious attention from the scientific community. The potential consequences of an impact were a major factor in the concern. Apophis is estimated to be about 370 meters, roughly 1,200 feet, across. To put that in perspective, that's larger than 3 football fields laid end to end. An object of this size carries immense energy. If an asteroid the size of Apophis were to collide with Earth, the effects would be devastating, particularly if it hit a populated area or the ocean. The impact energy would be equivalent to thousands of megatons of TNT. This would create a massive crater and generate powerful shock waves. An ocean impact could trigger enormous tsunamis, potentially inundating coastal regions thousands of miles away. A land impact would cause widespread destruction, firestorms, and eject vast amounts of dust and debris into the atmosphere. The scale of potential damage is why objects like Apophis are taken seriously. Determining the precise path of an asteroid like Apophis is a complex task. Scientists use telescopes to observe its position over time. These observations are then fed into sophisticated computer models that calculate the asteroid's orbit, taking into account the gravitational pull of the Sun, Earth, and other planets. Early observations provide a preliminary orbit, but there are always uncertainties. The longer an asteroid is observed, the more data points scientists have, and the more accurately they can refine their orbital calculations. This refinement process was crucial for understanding Apophis's future. Following its discovery, astronomers around the world continued to track Apophis. Each new observation helped narrow down the possibilities for its future path. The goal was to reduce the uncertainty in the orbital calculations as much as possible. Over the years, additional data from various telescopes, including radar observations, provided increasingly precise measurements of Apophis's position and velocity. This improved data allowed scientists to make much more accurate predictions about its trajectory, especially for the upcoming 2029 pass. Predicting an asteroid's path isn't just about gravity. There's another subtle force at play called the Yarkovsky effect. This effect is caused by sunlight unevenly heating the asteroid's surface. As the asteroid rotates, the heat is re-radiated into space. This re-radiation of heat creates a tiny thrust, which can slightly alter the asteroid's orbit over long periods. For an asteroid like Apophis, understanding and accounting for the Yarkovsky effect is important for predicting its path years or decades into the future. Scientists had to factor this into their models. As more data accumulated and the Yarkovsky effect was better understood for Apophis, the orbital predictions became much more precise. Scientists could confidently rule out certain trajectories and narrow down the likely path for the 2029 close approach. This was a major step in assessing the risk. The improved calculations allowed space agencies like NASA and ESA, European Space Agency, to make definitive statements about the 2029 encounter. The uncertainty that existed in the early days was significantly reduced, thanks to dedicated observation campaigns and advanced computational techniques. So what do the latest, most accurate calculations tell us about Apophis in 2029? The reassuring news from scientists is clear and unequivocal. Apophis will not collide with Earth on April 13th, 2029. The risk of impact on that date is 0. Instead of hitting us, Apophis will make a very close flyby. It will pass within about 31,000 kilometers, roughly 19,000 miles of Earth's surface. While this is incredibly close in astronomical terms, well within the orbit of some geostationary satellites, it is still a safe distance. To help visualize the 2029 distance, 31,000 kilometers is about 1/10 the distance between the Earth and the Moon. It's much closer than any large asteroid has come in recorded history that we know of. This makes the event scientifically significant, but not dangerous. Think of it this way: if the Earth were the size of a basketball, Apophis would pass by at a distance roughly equivalent to the length of a basketball court. It's a near miss, but a miss nonetheless. The trajectory is well understood and confirmed by multiple independent analyses. The high level of confidence in the 2029 prediction comes from the extensive tracking data gathered over nearly 2 decades. Scientists have observed Apophis through multiple orbits around the Sun. This long baseline of observations allows for extremely accurate orbital determination. Furthermore, radar observations have provided precise measurements of Apophis's distance and velocity. These measurements are incredibly accurate and leave no room for an impact trajectory in 2029. The science is settled for this particular date. While the 2029 risk is 0, what about future close approaches? Initially, there was a very small chance that the 2029 pass could nudge Apophis onto a path that would lead to an impact in 2036. This was the keyhole scenario, where passing through a specific point in space could alter its orbit just enough. However, subsequent observations and refined calculations, particularly after a close pass in 2020, allowed scientists to definitively rule out the 2036 impact scenario as well. The trajectory is now known well enough to predict its path for many decades into the future. Based on the latest data, Apophis has been removed from the Century Impact Risk Table, which lists asteroids with a non-zero probability of impacting Earth. It is no longer considered a significant threat for at least the next 100 years. This is a testament to the power of continued observation and calculation. This doesn't mean scientists will stop tracking it entirely. All large NEOs are monitored, but the immediate concern and the long-term threat probability have been effectively eliminated for the foreseeable future, thanks to precise astrometry. The 2029 close approach, while not a threat, presents an unprecedented scientific opportunity. It's rare for an asteroid of this size to come so close to Earth. Scientists plan to use this flyby to study Apophis in detail using various telescopes and instruments. They hope to learn more about its size, shape, composition, and surface features. Studying how Earth's gravity affects the asteroid during the flyby will also provide valuable data about its internal structure and density. This close encounter is a natural laboratory. The story of Apophis highlights the importance of planetary defense efforts. Identifying, tracking, and characterizing near-Earth objects is a crucial task. It allows us to understand potential threats and, if necessary, develop strategies to mitigate them. Organizations like NASA's Center for Near-Earth Object Studies, CNAOS, and similar groups worldwide work tirelessly to monitor the skies. They are the first line of defense against potential asteroid impacts, providing the data needed to assess risks and plan responses. While Apophis in 2029 is safe, the possibility of other, as yet undiscovered asteroids posing a threat in the future remains. This is why research into asteroid deflection techniques, such as kinetic impactors or gravity tractors, is ongoing. The DART mission, which successfully altered an asteroid's path, was a key step in this research. The knowledge gained from studying Apophis during its close pass could also inform future planetary defense strategies. Understanding the physical properties of asteroids is essential for designing effective deflection missions should one ever be needed. As April 13, 2029 approaches, expect to hear more about Apophis. It will be a major event for astronomers and the public alike. Many observatories will be tracking its passage, and there will likely be live streams and public viewing events. It will be a chance to witness a significant celestial event, a large asteroid passing remarkably close to our planet without any danger. It's a demonstration of both the dynamic nature of our solar system and the incredible capabilities of modern astronomy. So let's wrap this up. The asteroid Apophis will indeed make a very close approach to Earth on April 13th, 2029. However, thanks to years of dedicated observation and precise calculations by scientists around the globe, we know with certainty that it will pass safely by. There is no risk of impact on that date. This close encounter is not a cause for alarm, but rather an exciting opportunity for scientific discovery and a reminder of the vital work being done in planetary defense. We are tracking the skies, and for Apophis in 2029, the forecast is clear: a safe flyby. What are your thoughts on Apophis and planetary defense? Share them in the comments below. If you found this information reassuring and interesting, please give this video a thumbs up and subscribe to the channel for more insights into space and science. Check out my other videos on asteroids and NEOs right here.